Translation. Translation is all about moving points and shapes from one location to another. Consider the diagram below. How could we describe the movement of point A to each of the other points? So A is here. If we look at B and we consider going from A to B, we could use the grid to say that we go 6 units across and then 5 units up. And we could describe that as 6 units to the right and 5 units up. To go from A to C, we could go 8 units across and 3 units down. So we'd say 8 units right, 3 units down. And to go from A to D, we'd go 3 units to the left and 5 units up. An alternative way of expressing this is using column vectors. So for this first one, we could write that like this as 6, 5. Going to the right is a positive number, and it's the top number in our column vector, is the right and left. So 6 units right is expressed as 6. How we go up and down is the bottom number. 5 units up is 5. So for this one, that would be 8 and negative 3, positive 8 because we went right, negative 3 because we went downwards. And A to D would be negative 3, 5, and the top number's negative because we went left. We can apply these ideas to shapes and to a coordinate grid. So if we have a triangle here, ABC, and then a second triangle, DEF, if we're looking at translating triangle ABC to triangle DEF, we can just look at one pair of vertices that correspond, e.g. A and D. It should be clear that A and D are the same vertex in their respective triangles. So let's look at how A goes to D. It goes 11 across and 3 up. So we can express the translation as saying 11 units right and 3 units up, or we could write that as 11, 3 in a column vector. Here we have a second one, and let's look at A going to G. So that's 2 units left and 10 units down. So the translation is 2 units left and 10 units down, and as a column vector, that's negative 2, negative 10.